Okay, everyone, this is chapter 25, question 1. So, the question is the picture shows the Orion constellation on graphing paper. Calculate the electric potential energy of the configuration if each star in the graph is substituted by on electron and the declination slash right ascension are rescaled to 0.1 meters per small division. Okay, so I did most of this like on a computer. It was easier to see where they were at. So each of these little subdivisions, 0.1 meters, right? So in between each of one of these, there is one, two, three, four, five more smaller subdivisions. So they're each worth like 0.02 meters. And on the side here it goes for by twos. So that means that each one of these lines for the subdivisions is worth 0.04. So the math checks out. So 0.04. Yeah. Anyway, I was very tedious about this. I know some people measured it out, but yeah. Anyway, I named all of these charges. So Q1, Q2, Q3, Q4, Q5, Q6, sorry, Q5, Q6, and Q7. So I wrote down all the coordinates and I made a table with all of their coordinates. And we're gonna need that table. Um, so there is 7 total charges. That means there's gonna be 21 electric potential energy interactions. Um, so yeah, um, there's like a formula of showing that, but 1 second. This right here also shows it. It makes sure that we don't repeat any interactions, and it's a total of 21. So this could be a matrix, but our class is solely based on calculus. So yeah, we just gotta tough it out. Super time consuming. Yeah. So I started here again. So the reason I made the table there is because right here, the R value, this is the electric potential energy. That's why that's highlighted. Um, anyway, so that's the equation we have to use right there. These are the points. So sorry, this is R in between the points. 21 calculations in total. Yeah. So if you got Excel, makes it a little easier. So what I did was, again, I wrote down the graph. Then I calculated the R for each and every one of them. So it's x2 minus x1 plus squared plus y2 minus y1. It doesn't matter what x2 and x1 is, as long as you're consistent with your numbers. Anyway, that's what I did, all that under the square root. So I found all of the r's right here. Super fun. And I kept going. So I went some more, as you can see. I just kept going and done. Okay, so now that we have all the r's, we have to start to find the potential electric energies. So that's what I did. So since E is 1.6 times 10 to the negative 19, we're treating all of these like electrons. We can just square that. So it makes it easier. So that's exactly what I did there. Here I did that. And I did the same over here. Okay, I stopped at the potential energy of 6 because I realized on paper, you can just factor out all this stuff, then just put in all the R's. Saves a lot of time for showing your work. And then calculated it out. So potential from 1 to 6, which was the first part before I realized this is way quicker, is 3.5 times 10 to the negative 28. And the potential from 7 to 21 is 1.03 times 10 to the negative 27. So we used the, superposition principle, added them all up, and we ended up with a total of 1.38 times 10 to the negative 27 joules. Anyway, yeah, I hope that was helpful to some of you guys. It's not that hard. It's just really tedious. So yeah, good luck.